Albert Einstein was born at Ulm, in Württemberg, Germany, on March 14, 1879. 6 weeks later the family moved to Munich, where he later on began his schooling at the Leupold Gymnasium. Einstein's parents were secular, middle-class Jews. His father, Hermann Einstein, was originally a featherbed salesman and later ran an electrochemical factory with moderate success. His mother, the former Pauline Koch, ran the family household. He had one sister, Maria, who went by the name Maya, born 2 years after Albert. From the very beginning, Einstein showed signs of the curious mind that would revolutionize our understanding of the universe. Einstein would write that 2 wonders deeply affected his early years. The first was his encounter with a compass at age 5. He was mystified that invisible forces could deflect the needle. This would lead to a lifelong fascination with invisible forces. This simple childhood experience with a compass would later inspire his groundbreaking work on the fundamental forces of nature. Despite common myths about his academic performance, Einstein was actually an excellent student. Albert started his formal education at a Catholic school in Munich. The young boy ranked first in his class more than once, to the delight of his family. However, by the age of 12 he had taught himself geometry, showing his natural mathematical abilities far exceeded what was taught in school. Because of failed business ventures, the family moved several times during Einstein's childhood, finally to Italy when he was 15. Einstein's educational journey continued in Switzerland, where he would later graduate from the Swiss Federal Polytechnic in Zurich in 1900 with a degree in physics and mathematics. The early 1900s marked a period of struggle for the young physicist. Unable to find an academic position immediately after graduation, Einstein took a job at the Swiss Patent Office in Bern in 1902. This seemingly mundane job would prove to be a blessing in disguise, as the work analyzing patent applications for electromagnetic devices gave him time to think about fundamental physics problems, and the steady income allowed him to marry his college sweetheart, Mileva Merrick, in 1903. The year 1905 would forever be remembered as Einstein's miracle year or Annus Mirabilis. In this single remarkable year, while still working as a patent clerk, the 26-year-old Einstein published 4 papers that would revolutionize physics forever. These papers addressed some of the most fundamental questions about the nature of light, matter, space, and time. His first paper explained the photoelectric effect, proposing that light consists of discrete packets of energy called photons. This work challenged the prevailing wave theory of light and laid the foundation for quantum physics. His second paper provided mathematical proof for the existence of atoms by explaining Brownian motion, the random movement of particles suspended in fluid. The third and fourth papers introduced his special theory of relativity, which fundamentally changed our understanding of space and time. Einstein showed that space and time are interwoven and that the speed of light is constant for all observers. Most famously, this work led to his mass-energy equivalence formula, E equals mc squared, demonstrating that mass and energy are interchangeable. These groundbreaking discoveries came not from sophisticated laboratories or expensive equipment, but from pure thought experiments and mathematical reasoning. Einstein's ability to visualize complex physical scenarios in his mind and work out their implications through logic and mathematics set him apart from his contemporaries. Middle of journey, academic success and the general theory of relativity, 1905 to 1933. Following his miraculous year of 1905, Einstein's reputation in the physics community began to grow rapidly. His theories were initially met with skepticism, but as experimental evidence accumulated, the scientific world began to recognize the profound implications of his work. In 1908, Einstein received his first academic appointment as a lecturer at the University of Bern, finally leaving his job at the patent office. Einstein's academic career progressed swiftly. He moved to the University of Zurich in 1909, then to the German University in Prague in 1911, and back to Zurich in 1912. Each position brought him greater recognition and more resources to develop his theories further. During this period, Einstein began working on what would become his greatest achievement, the general theory of relativity. While special relativity dealt with objects moving at constant speeds, Einstein wanted to understand gravity and acceleration. He spent nearly a decade developing the mathematical framework for this theory, often working in isolation and pushing the boundaries of mathematical physics. In 1914, Einstein accepted a prestigious position at the Prussian Academy of Sciences in Berlin, which allowed him to focus entirely on research without teaching obligations. However, this move coincided with personal turmoil. His marriage to Mileva was deteriorating, partly due to his intense focus on his work and partly due to fundamental incompatibilities. Their marriage was dissolved in 1919, and in the same year he married his cousin, Elsa Lowenthal, who died in 1936. In 1915, Einstein completed his general theory of relativity, which described gravity not as a force, but as a curvature of spacetime caused by mass and energy. This theory predicted several phenomena that had never been observed, including the bending of light around massive objects and the precession of Mercury's orbit. The defining moment came during the solar eclipse of May 29, 1919, when British expeditions led by Arthur Eddington traveled to Africa and South America to test Einstein's prediction that light from stars would bend as it passed near the Sun. When the results confirmed Einstein's predictions, it made international headlines and transformed Einstein from a respected physicist into a global celebrity practically overnight. The 1920s brought Einstein unprecedented fame and recognition. He received the 1921 Nobel Prize in Physics for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. Interestingly, the Nobel Committee chose to honor his work on the photoelectric effect rather than relativity, partly because relativity was still considered controversial by some members of the physics community. Einstein used his newfound celebrity status to advocate for causes he believed in, including pacifism, civil rights, and Jewish rights. He traveled extensively, giving lectures around the world and meeting with political leaders, scientists, and intellectuals. His wild hair, casual dress, and quotable wisdom made him an iconic figure who transcended the boundaries of science. However, Einstein's later scientific work during this period focused increasingly on his search for a unified field theory, an attempt to reconcile general relativity with quantum mechanics and electromagnetic theory. This quest would consume much of his remaining career, though he would never achieve this goal. As the 1920s progressed into the 1930s, the political situation in Germany became increasingly dangerous for Jewish intellectuals. Einstein, who had been an outspoken critic of militarism and nationalism, found himself a target of Nazi propaganda. His theories were denounced as Jewish physics, and his books were burned in public demonstrations. Last Moment, Princeton Years and Final Legacy, 1933 to 1955. In 1933, as the Nazi regime consolidated power in Germany, Einstein made the difficult decision to leave Europe permanently. He had been invited to join the newly established Institute for Advanced Study in Princeton, New Jersey, where he would spend the final 22 years of his life. Einstein's move to Princeton marked a new chapter in his life and work. He settled into a comfortable house at 112 Mercer Street, where he would become a beloved figure in the small college town. Despite his global fame, Einstein lived relatively modestly, often seen walking to work in casual clothes, sometimes without socks, his characteristic wild hair becoming even more unruly with age. At Princeton, Einstein continued his relentless pursuit of a unified field theory, working tirelessly to find a single mathematical framework that could explain all of physics. He collaborated with various assistants and colleagues, filling countless blackboards with equations and theoretical constructs. However, this work largely isolated him from the mainstream of physics, which was rapidly advancing in quantum mechanics, a field Einstein had helped establish but with which he became increasingly uncomfortable. Einstein's famous disagreement with quantum mechanics led to his equally famous declaration that God does not play dice with the universe. He believed that the probabilistic nature of quantum mechanics indicated that the theory was incomplete, and he spent considerable effort trying to find deterministic explanations for quantum phenomena. His debates with Niels Bohr and other quantum physicists became legendary in the physics community. During World War II, Einstein's pacifist beliefs were tested by the rise of fascism. Though he had been a lifelong pacifist, he came to support the Allied cause and even wrote a letter to President Franklin D. Roosevelt in 1939 urging the United States to develop atomic weapons before Nazi Germany could do so. This letter helped launch the Manhattan Project, though Einstein himself was not involved in the actual development of the bomb. When atomic bombs were dropped on Hiroshima and Nagasaki in 1945, Einstein was deeply troubled by the destructive power he had helped unleash. He became a vocal advocate for nuclear disarmament and world government, believing that only international cooperation could prevent nuclear warfare. He famously stated, "A new type of thinking is essential if mankind is to survive and move toward higher levels." In his final years, Einstein remained intellectually active despite declining health. He continued working on his unified field theory almost until the very end of his life, driven by an unshakable belief that the universe must ultimately be comprehensible through mathematics and logic. Einstein developed an appreciation for music at an early age. In his late journals he wrote, "If I were not a physicist, I would probably be a musician. I often think in music. I live my daydreams in music." This artistic side of Einstein remained important throughout his life, and he often played violin as a form of relaxation and inspiration. On April 17, 1955, Einstein experienced severe abdominal pain caused by an aortic aneurysm. He was taken to Princeton Hospital, where doctors suggested surgery, but Einstein declined, saying, "I want to go when I want. It is tasteless to prolong life artificially. I have done my share, it is time to go." Albert Einstein's time on Earth ended on April 18, 1955, at the Princeton Hospital. Albert Einstein, touted as one of the greatest thinkers of the 20th century, died April 18, 1955, as a result of a fatal aneurysm in Princeton, New Jersey. Even in death, Einstein's brain became the subject of scientific curiosity. Despite Einstein's wishes to have his entire body cremated, the doctor who conducted his autopsy, Thomas Harvey, had other plans. He kept the brain aside. This controversial decision led to decades of study as scientists attempted to understand the physical basis of Einstein's extraordinary intellectual abilities. Einstein's famous discoveries. Einstein's contributions to science were revolutionary and far-reaching. Here are his most significant discoveries. 1. Special theory of relativity, 1905. Einstein's special theory of relativity fundamentally changed our understanding of space and time. The theory is based on two principles. The laws of physics are the same in all inertial reference frames. The speed of light in a vacuum is constant for all observers. This led to several groundbreaking conclusions. Time dilation. Time passes more slowly for objects moving at high speeds. Length contraction. Objects appear shorter in the direction of motion at high speeds. Simultaneity is relative. Events that appear simultaneous to one observer may not be to another. 2. Mass-energy equivalence, E equals mc squared, 1905. His mass-energy equivalence formula E equals mc squared, which arises from special relativity, has been called the world's most famous equation. This equation shows that mass and energy are interchangeable, with even small amounts of mass corresponding to enormous amounts of energy. This principle underlies nuclear power and nuclear weapons. 3. Photoelectric effect, 1905. He is also known for his discovery of the photoelectric effect, for which he won the Nobel Prize for Physics in 1921. Einstein explained that light consists of discrete packets of energy called photons, resolving a puzzle that classical physics couldn't explain. This work laid the foundation for quantum mechanics and led to the development of technologies like photoelectric cells and image sensors. 4. Brownian motion, 1905. Einstein provided a mathematical explanation for the random motion of particles suspended in fluid, providing strong evidence for the existence of atoms and molecules. This work helped establish the kinetic theory of matter and provided a method for determining Avogadro's number. 5. General theory of relativity, 1915. Einstein's masterpiece revolutionized our understanding of gravity. Rather than viewing gravity as a force, Einstein described it as the curvature of spacetime caused by mass and energy. This theory made several predictions. Gravitational time dilation. Gravitational lensing, bending of light around massive objects. Gravitational waves. Black holes. The expansion of the universe. 6. Quantum theory contributions. Although Einstein later became skeptical of quantum mechanics' probabilistic interpretation, his early work was crucial to its development. Explanation of the photoelectric effect established the particle nature of light. His work on specific heat helped develop quantum statistics. His contributions to the development of Bose-Einstein statistics. Legacy and impact. Einstein's discoveries transformed our understanding of the universe at both the largest and smallest scales. His work led to nuclear technology, both nuclear power and nuclear weapons. GPS satellites require relativistic corrections to maintain accuracy. Particle accelerators, designed using relativistic principles. Cosmology, our understanding of the Big Bang and cosmic evolution. Quantum technologies, lasers, solar cells, and quantum computing. Medical imaging, technologies like PET scans rely on Einstein's principles. Einstein's approach to science, combining deep physical intuition with mathematical rigor, continues to inspire physicists today. His famous thought experiments, such as imagining riding alongside a beam of light, demonstrate how visualization and imagination can lead to profound scientific insights. Beyond his scientific achievements, Einstein became a symbol of intellectual curiosity, social responsibility, and the power of human reason to understand the universe. His quotes on science, religion, politics, and life continue to resonate with people around the world, making him not just a great scientist, but a cultural icon whose influence extends far beyond physics. Today, more than half a century after his death, Einstein's theories continue to be confirmed by new experiments and observations, from the detection of gravitational waves to the imaging of black holes. His vision of a universe governed by elegant mathematical laws remains one of humanity's greatest intellectual achievements.